Hello, welcome, and thank you for joining my session. In this session, I will share some of the lessons I learned while writing infrastructure as code. By the end of this session, you will be able to pick up some of the tips I'm sharing and implement them in your environment. My name is Eran Bibi, and I'm the co-founder and chief product officer at Firefly, a solution that automatically transforms your cloud into IaC. Before that, I was the head of DevOps at Aqua Security, and in general, I am doing DevOps for more than 10 years. I really like to learn new technologies and share them with others. So let's start with understanding how to provision new infrastructure. In this example, I would like to provision a new Kubernetes cluster, a very common use case. So there is a plenty of ways to do that. There is some of the automation tools available in the ecosystem. There is the manual work you can do, aka the hard way. But you can use infrastructure as code. And in this example, I'm going to use Terraform because Terraform is one of the most popular framework for infrastructure as code. And if you ask him why to use infrastructure as code, so the answer is very simple. You can enjoy writing infrastructure and treating infrastructure like any other piece of software. You will save the manifest in your Git. You will enjoy versioning of your infrastructure, maintaining in your Git repository. But you can also enjoy peer review and CI/CD tooling, and basically shifting left security, vulnerability scanning, and also cost projection. And one of the main benefits of infrastructure as code is to use immutable infrastructure. So the idea in immutable infrastructure is to have a single template that basically can deploy your environment in multiple ways by using variable. So instead of doing the manual changes to your environment and basically treat your infrastructure as something that is a raw and then you are altering it manually, you have all of the infrastructure components in your manifest, and you can use this manifest to redeploy your infrastructure again and again, even in a disaster recovery scenarios. So the benefits of using an immutable infrastructure are very clear. You basically simplify your operation and you can reduce the total errors. So the first tip that I would like to share is using the dry pattern. Do not repeat yourself. So when maintaining infrastructure, it's very important to make sure you are not repeating your line of code. So for example, if you have a component that is shareable between projects, for example, a networking component like a VPC, you would like to create this component only one time and use it again and again, instead of each member in the team, once you need to introduce new infrastructure, you will not have to create a VPC component. You will use the same one that was created by your other team members. And one of the best way to do that is to use modules. So a module, it's a component that you are saving in your Git, and it's basically built to reuse it on other type of projects. So a VPC is a good example that I'm using, but you can basically modulize any other piece of software. So even if you have an EC2 instance, and this EC2 instance have a security groups, VPC, subnet, you can module all of the components and even the EC2, so you can basically reuse that piece of infrastructure and create revisioning for those modules and enjoy those components and the life cycle of the component. And one of the main benefits of using modules is basically you can pick up a module from the Terraform registry. So you can use other people's work that already be done and shared with the community. So you can not need to create by yourself all of your modules. So this is a screenshot of a typical tree of a model. So you can basically break up any other piece of infrastructure to a model and create a child model as well. So the idea is to have the main.tf file, which is contain all of the line of code that will describe the model, and then you have the variable tf that is basically describing all of the variables. So you can, for example, if you have an EC2 instance, you would like to deploy it with different kind of sizing for each other type of environment, then the instance type will be a variable in the main TF. The flip side of using variable, specifically if you are using a community variable models, is to make sure you are scanning it for misconfiguration and for malicious activity. So if you have one of the practices that you are using is pick up models from a public Git repository or from the Terraform registry, it's highly recommend to scan it for vulnerability and just to make sure what exactly that specific model is doing before you are provision the infrastructure in your cloud. One example of a malicious activity that can be done is you can take a model that from a single look can be look like innocent doing creating some, I don't know, Kubernetes cluster, for example. But it's in addition to the creation of the cluster, it's also creating an IAM role that have a cross-account connectivity and basically allowing the attacker to access your account. So this is like an extreme example, but this is just to raise the awareness that if you are using a public models that was created by the community, you just need to scan them before the usage to make sure that you know exactly what kind of component and usage are being done in this specific model. Another tip is just to keep the consistency. So when you are working with infrastructure as code in a small scale, it's not that important. But once you are building more and more infrastructure in your cloud based on your manifest, it's very important to make sure everything is aligned. It also can help your other team members to understand what are the naming convention and what are basically the best practice of writing infrastructure in your organization. A bit about state. So state file in Terraform is basically the representation of your state of the cloud as the Terraform understand its shape right now. So a state file is a file that is a human readable file, is in a JSON syntax. And when you are using Terraform locally, for example, if you are a single developer that's trying to provision infrastructure from your local computer, then in most of the case, you will use the default configuration where the state file is saved locally in your development environment. But when you are moving to use infrastructure as code in a scale, for example, you are sharing the templates with your members, your team members, or you have a CI/CD pipeline that basically clone the template and provision it for you. You need to make sure the state is available for others. So you need to put it on something that's called remote state. So Terraform have a function called backend. And for remote state, you can use several types of backends. And the most popular, of course, if you're using an AWS cloud, is to save it on an S3 bucket. And of course, because this piece of configuration is very important, I highly recommend to make sure you have a backup function for this state file. So if you are saving it on S3 bucket, or if you're using a different cloud, for example, Google Cloud, and you are saving it on Google Storage, you need to make sure you have some job that is creating a replicate of this state in case you have some disaster that automatically or accidentally removed the state file, or you did something like a human error kind of mistake. You need to make sure you are maintaining a backup for your state file, because without state file, it's very hard to import back all of the cloud configuration that you currently have into a state. And of course, if you are using a bucket that have a versioning capability, another tip for you is just to turn off the versioning so you can maintain the version of the state using the storage technology. So if you are using remote state, for example, in S3 bucket, and you have multiple teams or multiple pipelines that are provisioning infrastructure and always changing the state file, you need to make sure to have a lock-in mechanism in place. So you don't want that one of the member work will ruin the other member work if they are doing it in the same time. So if you are using an S3 bucket, you can basically create a DynamoDB table that will make sure you have a locking, and if somebody doing a change on that specific time, other member will not able to change the file and basically will need to retry once the file is not locked. Another major tip regarding state file is do not update it manually. So even though it's a human readable file, it's not a binary, it's just a JSON file. And in case you have an access for it, whether it's locally or remote, you must make sure you are not altering this file manually using your IDE, and you are using only the Terraform application to change the state file. Because once you are basically creating something manually to this file, you can end up with corrupted state file. And this is not something that you would like, a situation that you would like to be in it. So putting aside state file, one of the main capability of using Terraform is to use data source. So data source is basically a query syntax into the Cloud API, allowing you to use your infrastructure as code templates in much smarter way. So one of the main examples that we have for using data source, so this is a very typical use cases. If you have an AMI template and you would like to use a specific AMI in your Terraform configuration, but you don't want to put the exact ID of the AMI, you want something that is more dynamic. So in this example that I'm presenting right now, you can basically search for an AMI based on a certain tag. So we will create this data source that's called web, and this will bring you all of the AMI with a specific tag component that the value is web. Another example is to use regex kind of search. So you can put values like asterisks and basically enjoy all of the latest kind of Amazon Linux tool in this example. So with data source, you don't need to put explicit values on your template. You can just create a data source to query the AWS and having more dynamic and immutable infrastructure. Another tip is when you are using infrastructure as code and it's already embedded in your CI/CD pipeline and the organization is basically working on automatically workflow that provision infrastructure as code, you need to make sure not to bypass the IaC pipeline. So instead of doing manual work like provision infrastructure using Terraform, but then going to the console or doing to the API and doing change, you need to make sure that all of the change will be through the CI/CD pipeline. Because if you are not going to do that, you are can create infrastructure drift. So drift is a situation where the actual state of cloud is different from the one that is described on your manifest. And if you have scenarios that you are bypassing your IaC pipeline, you are basically creating drifts. So example of a drift is when I describe an IAM policy with Terraform, and this policy have a certain action, in this case a read-only action, like I can list all the DNS records and list the hosted zones. But if I'm going to the real state of cloud by accessing the AWS console, I can see that somebody add another action, which is asterisk, allowing everything, allowing this specific role to do everything in this type of resource, the Route 53, and basically giving full access. So this drift can be done by a human that accessing, like bypassing the infrastructure as code pipeline and change it, but it can be done by a third party that have permission to change infrastructure. So what I'm suggesting is to put some drift detection monitoring in place. So you can use one of the open source projects available like driftctl or qdrift, or even using Terraform Plan in a cron job to make sure you are always on top of the stuff that is changing in your cloud. I'm going back to the state file and now more focused about security. So state file, as I mentioned, is a major component in the architecture of using Terraform. But you need to make sure you are putting it on a safe place because it consists of sensitive data. So you can find, if you will examine the state file, you can find an access keys to your AWS. You can find DB credential like password and users, and you can also find certificates. So it's very important to make sure the state file is encrypted and no one else beside the Terraform application have access to read the state file. So to conclude, I will put here some of the takeaways that you can just put it in your environment right away after this session. So I recommend to use the dry pattern, making sure you have less line of codes that are reusable. Using Terraform data source and modules, it's something that will elevate your the way that you are using Terraform, and of course making sure your state file is on a safe place and you are using encryption to make sure nobody can access it. Also recommend to have a drift detection in your environment. And if you are using public models, just scan them before you are using them. Thank you very much, and I hope it was an enjoyable session. Feel free to check out Firefly at app.gofirefly.io, and you can reach me out to any other question after this session. Thank you very much. Goodbye.
Cool. So we do have some questions. Thank you for the talk, by the way, and sharing your experiences. So the first question is, have you tried Crossplane? If yes, do you think it could replace Terraform?
Yes, Crossplane, it's a great concept. It's also going to reduce the number of potential drifts because you can implement also a reconcile mechanism to make sure your cloud is also always aligned with the code. I didn't check it on scale, but the concept seems great to me.
Yeah, cool. And they're one of our sponsors, Abon. So, how do you scan Terraform modules in practice?
So right now, the open source scanners, and there is some great project like TFScan and Chekhov are supporting Terraform module scan. So it's very easy if you are implemented in your CI/CD, you just need to put that step of scanning, and in case there is a critical vulnerability, just fail the build.
Cool. Yeah. We've got a fair few, and we do have enough time. So how do you deal with state files for Terraform that do, for whatever reason, no longer reflect your resources reality? So basically, how do you deal with drift when drift happens?
Great. So in case of drift, there is basically two directions. It's either to align the code to be with the state of cloud, meaning adding and importing the necessary code blocks that are missing, or removing those resources that are not exist in the cloud, or the other way, which is doing basically plan and apply again and rebuild that missing resources and configuration drift there exists. And of course, again, one of the benefits of using Firefly is automating that kind of flows. But even without Firefly, you can do your own like in-house kind of reconciling and fix drifting system with the open source tooling that there is in the community.
Yeah, you could also use Terraform import, for example, to import stuff which has been created on cloud into your Terraform.
One of the prerequisites for importing is creating the configuration. So this is a step that you need to do. There is a few ways to do that, but once you are creating the configuration, and again, the typical example is that if you have a new EC2 instance that was created using ClickOps, like manually using the AWS console, you will have to create that resource block on your Git before importing it into your state.
Yeah, yeah, cool. Are there any unit testing frameworks for Terraform?
I think there are. I'm not using it. I don't have experience with using tests, but I think I saw some of open source tools that trying to solve this problem. To be honest, I didn't try it by myself.
Yeah, I find always the best when testing infrastructure. That's always a weird one, especially if it's a cloud-based infrastructure. You have to actually create it, so you have like a sandbox environment where you test that code yourself.
Exactly.
Cool. Best practices on releasing Terraform module repo releases. With all modules, where did you go? Stop.
Yeah, I think someone here in the question mentioned TerraGrant. So TerraGrant is a great framework to embrace the dry practice, which is do not repeat yourself and modules. And I think if someone would like to use modules, also checking TerraGrant is a great option. I saw an amazing customer of Firefly that using TerraGrant, so it seems like a great way to manage your infrastructure as code.
Cool. We're starting to get to the nitty-gritty. Terraform state file is corrupted. How would you fix it? So, sounds like somebody has had an issue before, or currently has an issue.
So I don't have the experience of fixing corrupted state files. So I think one of the items in my discussion was how to try to avoid corruption. And for that, I have two tips. The first one is do not manual edit the state file. I saw some use cases that on some cases, people trying to add or remove stuff from state file manually. So it's highly not recommended. And the other tip for that is make sure you have a lock-in mechanism. So if you have two people writing in the same time, it will not corrupt your Terraform file.
Yeah, definitely. Cool. Questions keep on coming in, so I'm going to choose the last 4. And then if anybody wants to keep on talking to Eran, I'm sure he's going to stay online, and he can also answer the questions on Slido. So the last 3-4 questions. How do you deal with state files for Terraform that do? No, that one we've done. Sorry. What do you recommend to use to make private cloud with on-prem DC so it would be as similar as possible using Terraform in AWS, Azure, OpenStack, VMware, so on and so forth?
Can you repeat that? I was
sorry. Yeah. What do you recommend to use to make private cloud with on-prem DC so that it would be as similar as possible using Terraform in AWS, Azure, OpenStack? So I think here the question basically is.
Okay, I think I got it.
Yep.
So eventually, I think Terraform specifically, it can be a very good solution because if we are talking about the providers that have a support, so it's not just the public cloud. You can also see provider for VMware vSphere, for example. So if you are looking for a framework that will help you to provision infrastructure, not just in the cloud, so maybe Terraform, this is the answer for you, and I hope I got the question right.
Yeah, if not, reach out to Eran directly. I'll do the last 2. Can Terraform modules get fetched directly from a Git repository instead of using a module registry?
Yes, of course. And it's highly, I see it in a lot of people work. Again, as part of my job in Firefly, I see a lot of Terraform configurations across many of customers, and this is one of the usage just to import modules directly from the Git.
Yep. And the last question, you have a few about drift detection, so I'll let you answer those after the session, but I'll go for this one. What is your opinion about Pulumi?
Great, Pulumi is great. If it's when you would like to describe infrastructure in the same language as your actual software, like Python or Golang. So this is a great way to do that, and it's a cool company, and I really like it.
Cool, awesome. You have a plethora of other questions, which hopefully you can answer online. But apart from that, thank you, Eran.